we should be here, 1.5. We're going to start with combinations of functions. So we can do adding, subtracting, multiplying, or dividing. So it could look like this, something like this. If you have a function f of x and a function g of x, when you're adding the two functions, you are literally just adding the like terms and combining. Same thing with the difference. If you're doing a function minus another function, you're literally just taking the first function and subtracting the other one. Multiplying, again, you're taking one function, multiplying another. So in this case, with this particular example, you're foiling it. And when you're dividing, a lot of times it's not going to simplify. If it doesn't simplify, that's fine. You just put one on top of the other, but it does have a domain restriction. Just because if you guys remember, the denominator can never equal 0. So you need to make that distinction. You need to include a domain restriction. You have to say that x cannot equal, in this particular example, positive or negative 1. All right, so adding, subtracting, multiplying should be pretty straightforward. Dividing also, just again, make sure that you set the denominator not equal to 0. All right, so let's take this part right here. This is another way to denote the combinations of functions. So you can write it as f of x plus g of x, or to shorthand it, you could write in one single set of parentheses f plus g of x. Same exact thing with the difference, same exact thing with the product and the quotient. All right, so this right here is kind of like the longer way to write it, just slightly longer, but this is more of like a shorthand way to write it. All right, so let's go ahead and start some examples. Let's start with this one. So this one wants us to find f plus g of x. Remember, f plus g of x is just another way to write f of x plus g of x. All right, so what I'm going to do is I'm going to take the function f of x, 2x plus 1, and I'm just going to add the function g of x, x squared plus 2x minus 1. All right. And all we have to do is combine like terms. Nothing combines with this x squared. 2x plus 2x is going to get you 4x. And 1 minus 1 is going to cancel out. So we have that f plus g of x is x squared plus 4x. All right. So that's the actual function. It then asks us to evaluate the sum when x equals 2. All you're going to do is just plug it into the sum. So it's just going to be f plus g. And then instead of the x, you're going to write the 2. And then this is the same as 2 squared plus 4 times 2. Just replace the x in the sum with 2. So we get 4 plus 8, which is 12. Let's say it just asked you to find the sum. Another way that you could find that number 12 is if you found f of 2 and then added g of 2. So that's just another way to get the same answer. If you plugged it into f of x, then you would have gotten 5. If you plugged it into g of x, you would have gotten 7, and then you would still get the same answer, 12. So that's just another way to get the same answer. All right, we can do something similar here. This is just finding the difference. So again, f minus g of x, this is just another way to write f of x minus g of x. So you're taking your first function f of x, 2x plus 1, minus your second function g of x, x squared plus 2x minus 1. All right, what's our only difference here? What do I do with that minus? Good, right? So you're going to distribute it to every term. In this set of parentheses, the 2x plus 1 you don't change at all. So this is just 2x plus 1 minus x squared minus 2x plus 1. And now you can combine your like terms. Nothing combines with negative x squared. 2x minus 2x cancels out, and then 1 plus 1 is just going to get you 2. So then we get f minus g of x is negative x squared plus 2. To find the value when x equals 2, you're just going to plug in that 2 for x. So to find f minus g of 2, this is going to be negative 2 squared plus 2. So negative 4 plus 2, which is negative 2. Okay, this one says to evaluate the product. So I want to find fg of x. Again, that's just another way to write f of x times g of x. So you're going to take your function f of x, which is x squared, and multiply it with g of x, which is x minus 3. This one's very straightforward. You're just going to distribute that x squared, and you're going to get x to the third minus 3x squared. So then this is your function fg of x. All right, and we can evaluate that at x equals 4. All you're going to do is you're going to find, you're just going to plug in 4 everywhere that you see an x. So this is going to be 4 to the power of 3 minus 3 times 4 squared. Simplify that is going to get you 64 minus 3 times 16, which is 64 minus 48, and then you get 16 as your final answer. Okay, let's try something like this now. The only difference here is that this is a division one, and when you're dividing, you are going to have a domain restriction. Even if this were just a normal function, you would still have a domain restriction because of the square roots. So the first thing I'm going to find is f over g of x. This is the same as f of x over g of x. So I'm going to take f of x. So f over g of x, we're going to take f of x, and that's going to go on top. On the bottom is going to be g of x, which is the square root of 4 minus x squared. Is there any other way that we can simplify that? Doesn't look like it, right? So we just leave it alone. There's nothing more that we can do there. But we want to find the domain of f over g. Let's see what restrictions we have here. Are there any restrictions on the top, the square root of x? What can we not have under the radical? What kind of numbers? Negative, right? Just negative, right? 0 is fine if it's on top. So I'm going to take that top, and I'm going to set it greater than or equal to 0, right? So I'm going to find that first. All right, if you remember from my honors class last year, right, I did this with 2 different colors. So I'm going to do the top in red, and then I'll do the bottom in another color just that we see what happens there. So the top we get when we square both sides, we get that x has to be greater than or equal to 0. All right, what's our domain restriction on the bottom? The bottom can never be what? Good, right? The bottom can't be 0, but this one is also under a radical, so what else can it not be? Good, right? So I'm going to set this strictly greater than 0. So I'm going to set the bottom strictly greater than 0. When you square both sides, you're going to get 4 minus x squared is greater than 0, strictly greater than. All right, and then we can go ahead and add x squared to both sides. You're going to get 4 is greater than x squared. And then you can square root both sides. Just treat it like an equal sign. You get x on this side, but what happens on the other side? Good, right? Plus minus 2. So how do we know exactly where we're going to have solutions? So this is one way to write it. My best tip for you guys is probably just to test a point. If you remember from last year, I would draw the little number line, and then I would plot a point right here at 2 and negative 2. Let's test the number 0, right? Where is 0 here in between, right? So this is where 0 is. When you plug in 0 into the original, does it work? 4 minus x squared, or 4 minus 0 squared. Is that a true statement? Yeah, right? So that does work. That means this entire region is going to work. The outsides are not going to work. All right? And since it cannot equal, right, we have a strict inequality here. What kind of circles can you put over those 2's? Good, right? Open circles. This is one way to think about the domain. If you learned another way and you want to do it that way, that's fine. But I would visually draw it. We also know that this right here, x is greater than or equal to 0 on a number line. We know that 0 would be right here. This would be a closed circle, and everywhere bigger than 0 would work. So to find the domain of this entire function needs to be the overlap between this domain and this domain. All right? Where does the purple and the red overlap? Between which values? So keep in mind, this one is 0 from here all the way up, and then this one is from -2 to 2. Okay, good, right? So from 0 to 2, right? So I'm going to take this and overlap it with this. It's going to overlap at 0, and we're not going to go beyond 2. So it's really just this region. So just this region and nothing more is going to be the domain of this function. So the domain, we can say, in interval notation, we can say it's from 0 with the little bracket. You can include 0, and it's going to go up to 2 with the parentheses, right? That one had an open circle. You can include it. You cannot include it. So there's your domain of that function. All right. Let me give you guys another one to practice. So let's say f of x is, I don't know, the square root of x minus 2. And let's just say g of x is x plus 1. And I want to find f over g of x and the domain. Let's start easy. What would f over g of x be? If I'm finding the quotient, what do I have to do to find that quotient? Yeah, right, you're just going to put f of x over g of x. This is going to be the square root of x minus 2 over x plus 1. So that is f over g of x. Let's find the domain now. Again, I'm going to do 2 different colors, right? So let's start with the top. What is our restriction for the top? Good, so I'm going to set the top greater than or equal to 0. Square roots can be 0, but they can't be negative. So I'm going to set the top greater than or equal to 0. You can solve this inequality. This is going to get you x minus 2 greater than or equal to 0. And then you get x is greater than or equal to 2. All right, I'm going to go ahead and draw that on a number line. All right, I see this best if you visualize it. So 2 is going to be right here. To draw x is greater than or equal to 2, what kind of circle would have to go on 2? Good. And then where am I shading? To the right or to the left? To the right, right? These are the numbers that are bigger than 2. So that's the top. All right, are you okay with the top? Good? Okay. What about the bottom? What can we not have on the bottom? Right, this one's just can't equal 0. It's not like the one that we did before, because this one's not a radical. This one just can't be 0. So all we're going to do is we're going to subtract 1 on both sides, and I get that x can't equal -1. Right? There's nothing more I have to do to that. -1 we can say is right here. If x can't equal -1, what kind of circle has to go there? Okay, yeah, if it can't equal -1, I would have an open circle. Are the values to the right okay? Yeah, right. Are the values to the left okay? Yeah, right? Everything's okay except for that -1. Are you okay with this little visual that I drew, right, of the domain? Where do the red and blue overlap? On 2, and then where else? To the right of it, right? So I'm going to start here at 2, and then it's going to go to the right. So then our domain has to be from 2 to infinity, right? It can go forever and ever. So this is our domain. All right, so I'm going to do a little bit of extra practice for you guys. Okay, so we're going to do composition of functions now. So composition of function is just a function inside of another function. So for instance, something like this, the way that you would write it is f with this little circle g of x, right? If it looks like that, you're finding g of x, you're going to work from the inside out, and you're going to plug that into f of x. So in this particular example, f composed with g of x, I'm going to take that function g and plug it into the x in f of x. All right, I'll show you what that would look like in this example. All right, so I want to find in this example 5, f composed with g of x, right? Again, this little circle means composed. It's a composition. So another way to write f composed with g of x, right? If that doesn't make sense to you, you can write it as f of g of x like that on the inside. And then what you can do is take the entire function g of x in this case is x minus 1, and you're going to put that into the function f. All right, so in other words, this is the same as f of g we know is x minus 1, so that's what's going to go inside of our function f. So this is going to be the square root of, instead of x, it's going to be x minus 1. All right, so another way that you can think about it is the square root of g of x. Right, g of x is what we put inside of x minus 1. All right, so this is our composition here. I'm just putting the function g into f. All right, the second part of it is it's asking us to find f composed with g of 2 and f composed with g of 0. So to find f of g of 2, plug that number right into this composition here. This is going to be the square root of 2 minus 1, which is the square root of 1, which is 1. All right, if you want to find f composed with g of 0, this is the square root of 0 minus 1. So the square root of -1, can that happen? No, so this one is undefined. So f of g of 0 is not possible. That's not allowed. Okay, so let's try the same thing with this one, example 6. So f of g of x, again, this is just another way to say f with g of x on the inside. All right. G of x in this case is this function 4 minus x squared. All right, so where is this going to go? F. Okay, good. Into this function for the x. Right, so this is the same as g of x plus 2. Right, because I'm taking that x into f of x and I'm replacing it with g of x. But g of x we know is 4 minus x squared. So this is the same as 4 minus x squared plus 2, which is the same as 6 minus x squared. All right, we can find these individual values later. at 0 and 1, but for now I want to find g composed with f of x. So again, this is the same as g with f of x on the inside, like that. So that means now you're going to take this function f of x with the x plus 2, and you're going to put that into the x that's in g of x. So this is the same as 4 minus, instead of x squared, this is going to be 4 minus f of x squared. So we can take that function f of x, which is x plus 2, and then square it. All right, 4 minus that. All right, this one requires a little bit more work because you have to actually multiply it out. This one, when you multiply it, right, this is a perfect square trinomial. It's going to be x squared plus 4x plus 4, and then I have 4 minus this number, this entire function. But again, minus, you're just going to take that minus and distribute it to this entire function. So this is going to be 4 minus x squared minus 4x minus 4. Lastly, the 4 and the 4 would cancel, and then so your final composed function would be negative x squared minus 4x. So now let's find the domain for f of g of x, right? So to find the domain of a composed function, you're going to find the domain of inside, domain of the inside, and then the domain of the whole thing. Domain of the whole thing. All right, I'll just call it that. So if I want to find f composed with g, remember that that's the same as f of g of x. All right, our inside function is g of x. So let's start with that. Does g of x have any domain restrictions? What can we not have in g of x? A negative, right? So I'm going to find the domain of this by setting it greater than or equal to 0. And then just like before, you can square both sides. This is 9 minus x squared is greater than or equal to 0. And then we get 9 is greater than or equal to x squared. Square root both sides, we get plus minus 3 is greater than or equal to x. And then just like before, you can draw it to kind of visualize it a little bit better. So this is negative 3, and then this is 3. Let's find a test point just to see what value works, right? I'm going to test 0 because that's an easy number. When I plug in 0, 9 minus 0 squared is greater than or equal to 0. That does work, so this entire region is going to work. So I'm going to color this in red. So this entire region works, and we are allowed to have that. So this is the domain of just g of x. And now let's find f of g of x, and let's see if that has any domain restrictions. So this is the domain of just g of x. So g of x, let me write that down. All right. To find f of g of x, again, we take g of x and we plug that into this x. That's an f of x. So what would it be? What am I squaring here? What's going to go in there? All of g of x, good. So I'm going to take all of g of x, and this whole thing is going to go under that square. So the square root of 9 minus x squared. What happens to the square root in the square? Good, they cancel out. So this is the same as 9 minus x squared minus 9. These are going to cancel out, and then so this is negative x squared. So this is the composition of the two functions. But what's the domain of that? Does that have any restrictions? X squared, negative x squared? Is it like a fraction or anything? Can I not have 0 in the bottom or something like that? This is pretty normal. So this domain is all real numbers. So the domain is all real numbers. Just by looking at this, you might think that the domain of the whole thing would be all real numbers, but again, it's the overlap of the inside, whatever the inside function is, which is g of x, and the whole thing. So in blue, I'm going to color in on this little number line the whole thing, right? The entire negative infinity to infinity you can plug into negative x squared. But again, the domain of the entire thing is just going to be the domain of the overlap. So where do the red and the blue overlap? Good, right? From -3 to 3. So that means the domain of the whole thing is going to be from -3 to 3. Okay, so for this one, okay guys, so some of you got it, good? Okay guys, I'm gonna do it. Okay. Keep in mind f of g of x is the same as f of g of x like this. So you can take this entire function, g of x. What is g of x? Someone read it to me. Yeah. Good, right? So we have that. This whole thing is going to go in this x in f of x. So I'm going to take this whole thing and it's going to go right there. Are you guys fine with that? Yeah. Okay. So let's actually plug it in. This is going to be 2 times, instead of x in this little spot, I'm going to put all of g of x. The entirety of g of x is 1/2 x minus 3, exactly as I see it. I'm not going to distribute anything right now, just exactly as I see it. And then there's the plus 3. All right? Is that part okay? Yeah. Good? I literally just took g of x, put it in for x. All right? What happens to 2 times 1/2? Let's actually simplify it now. 2 times 1/2, what does that get you? 1, so that cancels out. So that means this just gets you x minus 3 plus 3, which is what? Okay, good. That's just x. So that's f of g of x. Are you fine with that? Yeah. Okay. Let's do the same thing with g of f of x. This is, again, something like that. So let me take a different color. So that means I'm going to take all of f of x, and I'm going to put it in that x in g of x. So everything that I highlighted in green should be interchangeable. All right, so we're going to take all of f of x and we're going to put it in that x of g of x. So it's going to be 1/2. Instead of x, it's going to be 2x plus 3. And then we have that minus 3. So what I just highlighted in green is this f of x. That's replacing the x. Is that okay? So far, so good. I just took that f of x, put it right into g of x. And now you can simplify, right? 2x plus 3 minus 3, what happens inside? Good. So then this becomes 1/2 times 2x, which what does that get you? Just x, 1x, right? So just x. All right? So we found our compositions. All right, is that a little bit better? Okay, good. So one thing to note, that's it for today, but tomorrow we're going to have to do this process again. So if you didn't get it today, we're going to do more practice tomorrow. But what you can conclude with f and g, if you get that they're both x, then you get that f and g are inverses. All right? You don't quite need to know that definition right now, but for the sake of tomorrow, we are going to do the same process, and it is going to show something like this. We're going to show the work like that. If you get x in one and x in the other, then you get that they're inverses.